Hey, everybody, welcome back to another episode of Test Case Scenario. I am one of your hosts, Jason Baum, and with me, as always, is Evelyn Coleman. And joining us today is Titus Fortner. And we are so happy to be with you for another episode. And thank you, as always, to Sauce Labs for providing us the opportunity to make this show. We're just going to go right into it. Titus, who has been on the program in the past. Many might know him from, being one of, I would say, probably a testing celebrity. Is that an appropriate? Can we just call you that? No.
It's a small pond. Big fish in a
Okay.
small pond.
Big fish in a small pond. Okay. He's being. Look at that. He's okay. We'll just, how about pseudo celebrity? I love that term for people. Okay, fine. He's a testing celebrity. And we want to ask Titus the question that we asked last week on the program, which if you listened to, we asked the question, what is a test? And we got some interesting answers from Marcus Merrill and from Nikolai. Evelyn and I also participated in that conversation with some interesting ideas or thoughts to testing, but really it was Evelyn's idea, which is brilliant. And anyway, we want to see what Titus had to say and how it matched up with the others. So, Titus, we're putting you on the spot. What is a test?
Yeah, it's an interesting way to put it because that's not what is a good test. It's what is a test.
Right.
So I think a test is anything where you are validating an expectation, like just basically, I expect this to be true. I expect this to be a certain value, and is it? And so whatever you've done to lead up to that, usually you have like a range, act, and assert is how I break it down. It's the same kind of thing as the gherkin given, when, then, but it's like you set things up into a known state, ideally, you take an action, and then you make sure that action did what you expected it to do. And so that's generally how I talk about tests. Now you could have non-deterministic testing and all sorts of other things, but generally you're checking to see if what you expect to happen has happened properly. And if you get into good testing, you actually want to make sure that you are providing information about the system in a useful way. So you want to make sure that you are more confident that what you're doing is correct based on the test you've executed. And if you're not getting sufficient confidence about your system from what you're doing, you probably shouldn't be doing it as a test. How's that?
There's so much to unpack there. You mentioned like non-deterministic testing. You mentioned something that we did talk about on the previous podcast, which was like, what are we doing with the results of the test? And like, does that, like, if a test, falls in the woods and nobody records it, doesn't make a sound, like, is it actually a test if you're not doing anything with the results? Some of those things to unpack there. What do you think about that? If no one's recording the results, or no one's looking at the results, or it's not helping you gain confidence, as you said, is it still a test? Or is it just a bad test?
I love that. If you run a test in the woods, does it have value? Yeah, I think it's still a test. It's just not a useful test, right? So I am going to make the distinction that you're executing tests, but you're not getting the value, so it's not a good test. And this is what I see with a lot of people is they'll run these huge test suites and have huge failure rates, but they're only looking at a small subset of them, or they're not even paying attention to all the failures between test runs. I'm like, if you can't evaluate all of the failures before you make the next test run, like, why do you have that test suite? You really need to, and this also, as a submarine officer, right? Like on a submarine, you can't live with red indicators. If there is a warning light, you don't like, oh, we know that one's broken, so we're not going to pay attention to it. Like, no, like you shut things down. You're like, you get a maintenance team out there. If you can't fix it, you've got like big warning things, right? Like it's a serious thing because real problems can happen if you learn to live with broken indicators. And it's the same idea in testing. We've just gotten used to putting up with all of these false failures.
I just want to say that it was somewhat unfair to Marcus and to Nikolai because they only had 30 seconds to answer that original question.
Well, you can edit out extra stuff.
No, we don't edit on this show. This show, no editing.
It's real. No, I think your answer was actually pretty succinct. I think it probably didn't take more. Your original statement, the first one you gave, I don't think it went over 30 seconds.
I try to have a succinct answer that I can then talk about for an hour.
That is smart. As somebody who is also in the military, I do remember having some indicators that would be maybe yellow or even red that wouldn't affect the equipment. I think it's maybe a little bit different on a submarine when you're all underwater and you're underwater and a red light could mean that there's a leak or something. But my experience with the Patriot missile system, I feel like it's also very life or death, not my experience, but the system itself. And we have things that didn't render us non-mission capable that we would let go. I need to turn my notifications off.
Yeah, and like on a submarine, it's like if you get used to some indicators are just wrong and then you assume that it's probably fine, like we don't even allow that on the easy things, because if you get used to it on the easy things, then the ones that actually could be a problem and you like, oh, that's probably fine, it's probably the thing that we saw last week or whatever it is, and then you all drown.
Yes, less risk of drowning when you're in the well.
The stakes are a lot lower in testing, which is why I got out of submarines and into testing.
But are they? Because can a single because you're still testing, right? So you're testing, doesn't matter what you're testing. I mean, you could be testing something that is life or death, right?
Sure.
So,
but it's websites, not nuclear reactor.
What if it's the website? No, I'm just kidding. I don't know. I could.
I have a sidebar question, but it reminds me of like the fact that a lot of these military pieces of equipment, I think this is common knowledge, but things like, oh, there's more technology in your like TI-84 calculator than there is in like the space shuttle or something, because we use a lot of this old technology to keep things safe and to keep things simple. But we still write in those languages to produce these things. So someone has to be out there testing things in these old languages. And I guess
some of those, I'm sorry to cut you off.
It's okay. Go ahead. I was going to say some of my questions around this are like, do you use new methods to test these old technologies, or do you have to still rely on some older, like whatever we had before, like visual testing or functional testing? Like, do you have to go back to these old school methods of testing in order to create this software in these old languages?
So see, I finally get to use some computer science coursework knowledge here, because there are some programming languages that are actually designed to prevent bugs, designed to prevent you from being able to write code that has bugs. And obviously you can find a way to write a bug in humans are resilient, but there are certain more difficult to use programming languages that are really designed to make it very difficult to get something that's going to cause a significant failure. And those aren't very performant languages, so you're never going to be able to write a website in Ada probably, but being able to test is what allows us to kind of go fast with these higher level like read a quote recently, the history of software development is increasing layers of abstraction, right? Like, so you're constantly making it easier to do a high level thing to do lower level things, and the higher level you get, the more important it is to test, because there's so many layers underneath it that you don't need to understand right now, but you do need to make sure that they're working the way that you intend, so that you're getting the result that you want for your users, the company, etc.
So do you use the new methods to test the old things? You're saying you don't have to, because some of them wouldn't be pertinent at that layer.
There's less need. If you're doing the really hard, really slow, really difficult languages that are doing low level stuff, there isn't as much need to do the kind of testing we have to do right now. I mean, I love Ruby. There are so many ways to screw up Ruby. right? Like you can do, and like you can dive into the internals of anything and change it anywhere you want. I get frustrated writing Java because of all of the immutable data structures that they like, and like, no, you can't change this once you've created it. I'm like, but I don't know what I need to know. When I created it, I need to change it. I'm like, no, you can't. I'm like, so I have to create a whole new object with, anyway. The point being that the higher level abstraction you get, the more likely it is you've screwed something up, and so the more intensive your coding needs to be. Whereas a lot of the older things, it's just not that complicated, and you're already working with the low level stuff in a way that, I don't know, someone that knows computer science a lot better than I do is going to come along and say that I'm wrong on all of these things. But
does that change testing though, as our computers and the capacity for the computers become more performant? Like, these computers that are way faster, does that mean that we reach some kind of peak with abstraction and then we kind of come back down the other way? Does that lessen the need for testing in the future?
So the bottleneck for functionality by and large is people, not machines. So like the human power it takes to create the code. And so if you optimize the languages and the features that you're using to make it faster for the human to do the things. I mean, it's one of the things why I think Ruby's awesome, right? Ruby is slow, but it's a lot easier for a developer to write it. So like Rails came out and it was like super easy to knock out a website because it made it easier for the person to do it, even though the execution was a little slower. And I think the more we do that, the harder it is to ensure that we're doing all of the right things, or what we did is actually accomplishing the thing that we thought we did. I mean, that's a lot of unit tests, right? Like, did we write the code we expected to write, or acceptance tests, technically? Did we actually write the code we thought we wrote?
I'm out of thoughtful questions. Thank you. I thought some of those questions were all right.
So when is something not a test?
So yeah, so I've seen a lot of, so like my basic answer to that is if it doesn't have an assertion. So I see a lot of code that just gets written and there's no assertion. So like, what is the intention of this code? And if it isn't obvious what the intention of the code is, it's really hard to consider it a test of something, because, like if it's the lack of an exception, which exception and why? So you really need to. I have taken over test suites that didn't have exceptions, that had a lot of failures, because they were expecting that if it failed, there'd be an exception, and that just wasn't true. It passed fine without an exception, but the thing that they intended to happen to check against, it was happening or not happening, and the system was broken.
And can test have a gray area, or is it simply just pass, fail?
So there is a concept in testing called soft assertions, where essentially you would run through a whole flow, and anything that's not ideal, you would just add it to a list. And then at the end, you would have this list of things that, oh, I was expecting this content, but it was actually this. I was expecting this page, but it's actually this. I don't care for that approach. I'm a big fan of, like what we say at Sauce Labs, short atomic autonomous tests, where each test is focused on one thing, and you know what the state is that you're starting with, the action that you're taking, and you have a specific understanding of what that action is supposed to do. And the longer you flow through things, the more likely you end up in the wrong state somewhere, and you're not actually evaluating the functionality you think you're evaluating. And so gray area, you've got those where like you don't really, like it was hello without an exclamation mark instead of hello with an exclamation mark. Do you actually care? And you can have a whole bunch of soft assertions like that. But then again, if it's not keeping you from releasing the build because there's a problem, like, are you wasting your time? So I think there's a lot of tests that you can write that are just a waste of time, that aren't actually providing value. I think another thing is a lot of people like, oh, it's easy for me to write this test, so we should run it. And it's like, well, actually the cost of that test is in the maintaining of that test, maintaining the test suite with that test. And if you write a whole bunch of minor, not super important tests, like any one isn't going to be a problem, but the whole test suite with all of those in it is a problem. Like, it's not just a linear, it becomes exponential. It's exponentially harder to maintain a larger test suite. And so it's really important that you're only running the tests that actually matter. I can't tell you how many times at former companies I'll like file a bug and then I get, back next day, priority 5 won't fix. I'm like, well, why am I running a test if you do not care if it passes or fails? Like, that's wasting everyone's time. Like, sit down with product. Like, what else am I running here that you don't actually care if it breaks? Let's talk about that.
Who should make that determination in your opinion? Like, we have these tests that are like soft assertions. We have these tests that are maybe not being looked at, or they're low priority, or they were written just because they were easy. But I feel, and then maybe this can speak to some of the testers that listen. Hello out there. But I feel like sometimes people who write tests are just given the test that they're supposed to write. So who makes this determination, in your opinion, of whether something's important or not to test?
And is that still true, what you just said? Because I feel like in some companies
it's moving.
Yeah, it's moving,
Yeah,
right?
it's moving.
All companies are at a different phase in how they're choosing to do things. I used to jokingly and somewhat lovingly refer to them as legacy QA managers. The approach that we have, version 1 of the move to automated testing was, let's take what manual testers do and just have a robot do it. And that's a bad idea, mostly because humans and computers are good at different things. And you want to leverage what a computer is good at in order to get the same level of confidence that you were getting from a manual tester. So they're doing completely different things. Manual testers are going to find so many more things that an automated test isn't going to find. But then you can scale up the automated tests in a way that you're actually overall getting more information for the same resources that you would with manual testing. And that's the whole reason for moving to automated tests. But don't then hamper your automated test approach by pretending it's faster humans, because it's not.
Who should determine which tests are important, do you think?
So each team is going to have a different manager, a different group of people collaborating on what things need to be tested and how. And my wish is for practitioners and for testers to push back when things are asked for that is going to make things harder, not even just for you, but for your team and for whoever replaces you when you leave the company. What is it that's maintainable? Managers are often looking for coverage, and that's great as long as you have the resources to maintain it. And I think a lot of people overestimate or underestimate how many resources are needed to properly evaluate the results of the tests that you're running, unless you have a really, like, the teams that I've seen with like really well-run test suites where high confidence that things are passing are good, and if they're failing, it's bad. They don't have large test suites. They've got small, focused test suites that are focused on providing the most value with the resources that they have.
That's a good answer. Thank you.
A very good answer. And I feel like I have so many questions about who is a practitioner and who's a tester, and perhaps we should be asking those questions another day. But I feel like, Titus, you might have some opinions on that.
There's so many. That's one of the hard things in our industry right now, is so many different titles with so many overlapping responsibilities.
No, Titus, if you're on the podcast, you have to come out here and say, like, this is how it is. These are the opinions. These are the generalities. You can't come over here with it depends. Like, we need the hard takes. If not from you, then from who, Titus?
Oh,
I kind of want my life philosophy to be, sometimes I disagree with myself.
that's fair. That's a good philosophy. Sometimes you disagree. Does anybody really know anything and everything?
Everything is context dependent. I think the more time I've spent at Sauce Labs, the more I've seen different contexts where things work. And it's one of the reasons I get very frustrated with very opinionated people who have only seen one context and insist that their way has to apply everywhere without really understanding. And part of it's just frame of reference. Part of it's, going out and learning to experience different things in different places, but there needs to be a certain curiosity of why is this the best thing. One of my friends, legit friend, gave a talk at Selenium conference a few years ago with this pitch, and then someone asked a question with the obvious reason why what he pitched was bad, and he didn't have an answer for it. Like, it just didn't cross his mind that was a possible objection to what he was. It's like, you have to know why you wouldn't do something to know why you should do that, if that makes sense. What's the trade-off that you're choosing in spite of? I don't know. Now we're just getting into like test framework thoughts and abstractions and how to do nerdy technical things. But
we will have you on for that. Do not worry.
We'll always have Titus. Titus, you should be a regular on this show, I think.
We'll start having 6-hour podcast episodes. It'll be great.
Nah, we could keep you. We'll rein you in. I'm gonna install in your house like a little red buzzer or something. A red light.
How will anybody get to work on time? They'll be listening to you on their commute, and then they'll have to stay in the car to continue listening to you, and they'll miss their whole workday. And then in a year, there won't be any testers, Titus, and the economy will collapse.
Subscribing to your podcast because it took all of my hard drive space on my phone.
Awesome. Well, thanks so much for being on the podcast. I hope you come back soon, for real. Like, we really would like to have you on more. And stay tuned for future episodes with Titus and future episodes with us. Thank you to Titus. Thank you to Evelyn. Thank you to me. Why not? I throw in a pat on the back. Right? I'm here. I deserve a thank you. Yeah. This has been another episode of Test Case Scenario. We hope you'll come back next time. It's been a pleasure, and we'll see you then.